Well, Mars is very old, and Mars is more or less dead. One of the things that it's sure is that Mars has no plate tectonics going on. And if we find the appropriate analogues at Taupo, and then in the Dresser Formation, but especially at Taupo. Well, Taupo is in New Zealand, and New Zealand is sitting on a subduction zone. So plate tectonics has got a lot to do with the hydrothermalism in New Zealand. But, there is a but. And the but is that Taupo is a huge volcanic caldera and is one of the few super volcanoes in the world, which means that it's not just the plate tectonic that's happening, that is having its run, but there is something more. And the something more is called a hotspot. So, the Mars has been dead, probably, at least since the same age of the Dresser Formation stromatolites, so about 3.5 billion years. And that is the age of the crust of Mars. I mean, one of the age which we infer is the age of the crust of Mars. So the age of the Dresser Formation, the stromatolites in Australia, and the age of the crust of Mars are the same. So here we have a fantastic analog. The Dresser Formation, Taupo, Mars. So potentially we need to look for something similar to a hot spring on Mars. And if you look at the morphology of the red planet, you will find it. The morphology of the red planet has places where you do find the evidence of ancient water running, but also you have evidence of volcanic craters nearby. So a volcanic crater, an hydrothermal spring, and the river. But again, you pointed out, how can we do that if plate tectonic is dead? But at Taupo, I mentioned, there is a huge hotspot. So let's think about the possibility that on Mars you had hotspots, and the hotspots actually created hydrothermalism. So then you had a land, because you didn't have an ocean, you had a land, you had the possibility, because we know that at that time there was a form of liquid, there must have been water, so you have the water, and you probably have also you have the building material to build the stromatolites, like silica, so we could have silica stromatolites. And as we learn from the sinters in Taupo, we know that silica can protect the cyanobacteria from ultraviolet light. Now then, we have to break the crust of Mars to have volcanism. And here is another idea. It's a little bit of a crazy idea, but it's not my idea. I learned it from Martin von Kranendorf. The idea is that you can hit Mars with a big meteorite and poof, you form a huge crater. But on the opposite side, you break the crust make cracks, and here you can have your magma, your hydrothermalism, water coming, you can have a volcano. And that could be a great explanation of the fact that we do find evidence that life might have been on Mars. One of the hints to life on Mars is the fact that from what we recovered, what we know through the rover expedition, is that there are some minerals which are related to bacteria on Earth. One of these minerals is called jarosite, and jarosite has been found off Mars. And jarosite is typical, is an iron sulfide. Jarosite is typically associated to microbial mats thriving in mine drainage, where the pH of the water is 3.5. And thinking about what the atmosphere of Mars was, which was loaded with carbon dioxide, it's very likely that the waters on Mars were extremely acidic. And I think that in the lecture that Jim Jackson gave, he mentioned that. So you have a very acidic water, and you need bacteria living in that water. So now we know by looking at awful mine drainage, those that you look and they have the colors like bright green, bright yellow, and you think, oh my God, those are the places where acidophile bacteria thrive. So put everything together. You have acidic water, you might have hot water, and then it might cool off. You have the possibility to protect life by precipitating minerals. So this gives you the opportunity to think, I know where to look for past evidence of life on Mars, because now I have all the details, all the information I need.